Okay, STAWA set 18 is fairly straightforward, particularly part 1. I'll just go over the first one as a general way of looking at it and point out a couple of tricks with H and M. So firstly, when we look at part 1, we've got our set of rules for particular substances for their oxidation numbers. And we know that oxygen is always -2, unless it is molecular oxygen or ozone, in which case it is 0, or alternatively, unless it's in a peroxide, like hydrogen peroxide, in which case its charge is -1. But in this case, none of those apply. So we know that oxygen is -2. So we can say the following, that 2 times -2 plus whatever the value of S is going to be equal to 0. And I say that to you because the overall charge of the sulfur dioxide molecule is 0. So what have we got here? We've got -4 plus whatever S is equal to 0. We know, therefore, that -4 plus 4 equals 0. So therefore S, the oxidation number of it, is +4. And that way of writing an equation is a very, very simple way of doing these particular things and thinking about these particular things. Remember our rule that for a neutral substance it's got to add up to 0, but if it were a charged ion, for example, it would have to add up to the charge of the ion. Now let's have a look at 1H. 1H is a bit of a swine. It's asking us for what is the oxidation number of the copper. And these funny square brackets around here indicate that what we're dealing with here is a complex. So we have ammonia molecules, 4 of them will form a complex with copper. In other words, what happens, those ammonia molecules, in this case if you were to draw a Lewis diagram of it, would have a lone pair on the nitrogen. These are 2 electrons that might interact with the copper, and in fact these are what do interact with the copper. Overall, the charge of the copper is saying that Cu plus 4 times 0, okay, there's the 4 of them, there's the 0, the overall charge for the ammonia is equal to +2. So, what number plus 0 is equal to +2? Well, that's fairly easy. Therefore, the copper equals +2 in this case. Okay, finally we're going to have a look at this funny little molecule methanol, and we're interested for 1M on the charge of the carbon. So again, the easiest way of dealing with these carbons is actually to play around with it a little bit for an equation. So we're saying whatever the C is equal plus, and we know that hydrogen in the case of carbon is going to be 3 times -1, 3 times +1, okay, plus -2 for the oxygen, plus 1 is going to be equal to 0 again. That's an easy enough thing to do. So 3 plus -2 is going to be 1, plus 1 is equal to 2. So the oxidation state of the carbon in this particular case is going to have to be 2, isn't it? So therefore C equals 2. Have I made a mistake, or is it -2? Let's go back and check that again. 3 plus 1, okay, so there's 3 here, -2 is going to be +1, +1, so to counterbalance that, the carbon has to be -2. And there you go, pretty much straightforward, just adding up the numbers and following the little table of rules that you see present on page 184 of your STAWA manual. And that's that.